expand 2x minus 3 upon x raised to the power 6. So since we know well by binomial expansion a plus b raised to the power n is equal to a raised to the power n plus n a raised to the power n minus 1 b plus n minus 1 upon factorial 2 a raised to the power n minus 2 b square plus so on to b raised to the power n. Here we have written n in place of nc1 because the value of nc1 is n and this is the value of nc2. So if we consider this and if we compare this with the general binomial expression, so we have a is equal to 2x and b is equal to minus 3 upon x and n is equal to 6. So if we replace a by 2x and b by minus 3 upon x and n by 6 in this expansion, we have 2x minus 3 upon x raised to the power 6 is equal to a raised to the power n. Our a is 2x, so 2x raised to the power n is 6 over here, so we have 2x raised to the power 6 plus n, that is 6, a, that is 2x raised to the power n minus 1, that is 6 minus 1 in this case, so that will be 5, and b is minus 3 upon x, minus 3 upon x plus in the second term n minus 1, that is 6 into 5 upon factorial 2, a is 2x and the power will decrease by 1, so it becomes 4, and the b is minus 3 upon x and its power will be square, that means it will increase in every term by 1, so now it becomes minus 3 upon x whole square. So in this way, if we proceed, the next term will be 6 into 5 into 4 upon factorial 3, 2x raised to the power 3 minus 3 upon x whole cube plus 6 into 5 into 4 into 3 upon factorial 4, 2x raised to the power 2, that is 2x square, and minus 3 upon x raised to the power 4. And in the next term, we have 6 into 5 into 4 into 3 into 2 divided by factorial 5, 2x raised to the power 1 and minus 3 upon x raised to the power 5. And in the last term, b raised to the power n, that will be minus 3 upon x whole raised to the power 6. 2x raised to the power 6, that will be 2 raised to the power 6 into x raised to the power 6. So 2 raised to the power 6 into x raised to the power 6 plus in the next term, if we talk about the numerical coefficient, that will be 6 into 2 raised to the power 5 and minus 3. So we write first numerical coefficients like 6, 2 raised to the power 5 and minus 3, then x raised to the power 5 upon x raised to the power 5 upon x. In the second term, as we know, the value of factorial 2 is 2, so 2 will divide 6 3 times and 3 will multiply 5 and we get 15. So first numerical factor in the next term will be 15. From here we have 2 raised to the power 4, 2 raised to the power 4, and from this we have minus 3 square, and the variable factor will be x raised to the power 4 in the numerator and x square in the denominator, x raised to the power 4 upon x square. Now come to this term. Here factorial 3 is in the denominator, and as you know well, factorial 3 is 6, so this 6 will divide this 6 and we are left with only 5 into 4, that is 20. First numerical factor in the next term will be 20 and next numerical factor will be 2 raised to the power 3 multiplied by 2 cube multiplied by minus 3 cube. And if we talk about the variable factors, there will be x cube in the numerator and x cube in the denominator, because whole power is 3 over here. So we have x cube upon x cube. If we move on to the next term, that is 6 into 5 into 4 into 3 upon factorial 4, and as we know, factorial 4 is 24, so that 24 will cancel this 6 and 4, because 6 4 is 24 in the numerator we have. So 24 will cancel factorial 4, and we are left with only 5 into 3, that is 15. So first numerical factor in the next term will be 15, and next 2 square and minus 3 raised to the power 4. And we talk about a variable factor, so that will be x square in the numerator and x raised to the power 4 in denominator. So x square upon x raised to the power 4. Now come to the second last term, that is 6 into 5 into 4 into 3 into 5. And as we know, factorial 5 will cancel 2, 3, 4, 5 all, because 5 into 4 into 3 into 2 can be written as factorial 5. So this factorial 5 will cancel factorial 5, and only we have here 6. So first numerical factor is 6 over here, then multiplied by. From the next factor we have 2 numerical factors, so 2 multiplied by, and from the next one we have minus 3 whole raised to the power 5. Minus 3 whole raised to the power 5. And the variable factor will be x in the numerator, x raised to the power 5 in denominator. So we have x upon x raised to the power 5. And the last term is minus 3 upon x raised to the power 6, which may also be written as plus minus 3 raised to the power 6 upon x raised to the power 6. Now let us solve further. Next step. So 2 raised to the power 6 will be 64. 64 x raised to the power 6, and here we have minus into plus minus, and if we multiply these three numbers, 2 raised to the power 5 is obviously 32, so 32 and 6 3s are 18, so that is 576 is the numerical factor after simplification, and we have x raised to the power 4. In the next term we have minus 3 square. As you know well, if there is even power of minus, it becomes plus, so the coefficient will be plus, so we will write plus over there, and we have to multiply 15 into 2 raised to the power 4, which is equal to 16, and the next number is 9, so we have to multiply it by 9. So we have 2160, and 2 powers are reduced from the numerator, so we are left with x square in terms of variable. In the next term, if we simplify, that will be 20 into 8 into 27. There is cube of minus, so it becomes negative because exponent is odd, and if we multiply 20 and 8 and 27, we get 4320, and x cube will cancel x cube. No variable factor will be over there in this term. Now talk about this one. The exponent of a negative integer is even, so its result is positive, so next term will be positive. Then we have to multiply 15 and 2 square, that is 4, and 3 raised to the power 4, that is 81. So first we multiply these three numbers, so we have 4860. 2 powers are reduced from the denominator, so we have 1 upon x square. Now the second last term, we have to simplify first the numerical factors. So now the minus 3 raised to the power odd, so the result will be negative, so we have to write down minus first, and then we have to multiply 3 raised to the power 5 and 12, so 3 raised to the power 5 will be 243, and we have to multiply it by 12, so we get 2916. And variable factor will be 1 upon x raised to the power 4, because 1 power is reduced from the denominator. So we have 1 upon x raised to the power 4. In the last term, minus 3 has an even exponent, so its result will be positive, so plus, and 3 raised to the power 6 is equal to 729. So finally, required expansion of 2x minus 3 upon x raised to the power 6 is equal to 64 x raised to the power 6 minus 576 x raised to the power 4 plus 2160 x square minus 4320 plus 4860 divided by x square minus 2916 upon x raised to the power 4 plus 729. Now the second important type of question based on binomial theorem is find the coefficient of x raised to the power 5 in the expansion of x plus 1 upon x cube raised to the power 17. Here we have x plus 1 upon x cube raised to the power 17 as the binomial expression, and we need to find out the coefficient of x raised to the power 5. So in this type of question, first we write general term, that is tr plus 1 is equal to ncr a raised to the power n minus r b raised to the power r. And then we compare this given binomial expression with the standard binomial expression, that is a plus b raised to the power n. So we have a is equal to x, b is equal to 1 upon x cube, and n is equal to 17. Then we substitute these values in this identity. So we have tr plus 1 is equal to n is 17. So 17 cr. A is x, so x raised to the power 17 minus r. B is 1 upon x cube, so we have 1 upon x cube whole raised to the power r. Now we simplify a little bit this one. 17 cr x raised to the power 17 minus r, and here if we open up this bracket, this power will go on 1 and x cube both. So we have 1 raised to the power r, that is 1. And x raised to the power 3 whole raised to the power r will be x raised to the power 3r. So by theory of indices, this expression may be written as 17 cr, and because the bases are same, powers may be written as x raised to the power 17 minus r minus 3r. This 3r will be subtracted from the exponent of the numerator. So we have 17 cr x raised to the power 17 minus r minus 3r becomes minus 4r. After writing this kind of general expression for any arbitrary term r, what we have to do next? We have to equate this exponent to 5, that is the given exponent in our question. So we say let 17 minus 4r is equal to 5. And in solving this equation, we need to find out the value of r. So 4r should be transposed to this side and 5 to this side. So we have 17 minus 5 is equal to 4r, or 4r is equal to 17 minus 5 is 12, or transposing 4 to this side, 4 will divide 12. So we get r is equal to 3. So after finding out this value of r, we need to substitute this value of r in our tr plus 1, which we have already calculated in terms of r. So let it be equation number 1. So substituting this value in equation number 1, we have, if we substitute this value of r in left hand side, we get t4. That means x raised to the power 4 will be created in the fourth term. And here we have 17 c3, and here we have x raised to the power 17 minus 12, that is 17 c3 x raised to the power 5. You may also write directly x raised to the power 5, because automatically it will be 5, because we have compared this expression to 5. We have taken this expression equal to 5, that the coefficient of x raised to the power 5 in the given expansion will be 17 c3. Coefficient of x raised to the power 5 is equal to 17 c3. We will also simplify 17 c3, or we may leave our answer over here. The next important type of question based on binomial expansion is find the term independent of x in a given expansion. So we need to find out here the term independent of x in the expansion of 3 upon 2x square minus 1 upon 3x raised to the power 6. First, we have to compare this expression by a plus b raised to the power n. So we get a is equal to 3 upon 2x square, b is equal to minus 1 upon 3x, and n is equal to 6. Then we write tr plus 1, the identity for tr plus 1, that is ncr a raised to the power n minus r b raised to the power r. So substituting the values of a, b and n in this identity, we have t r plus 1 is equal to 6cr 3 upon 2x square whole raised to the power 6 minus r and b minus 1 upon 3x raised to the power r. Now simplifying this, we have 6cr and here we have 3 upon 2 raised to the power 6 minus r and x raised to the power, this 2 will multiply 6 minus r when we open up this bracket. So this power will be implemented on 3 upon 2 and x square both. So 3 upon 2 will have only 6 minus r, and if we take this 6 minus r exponent of x square, so both the exponents will be multiplied together and we have x raised to the power 2 6 is 12 minus 2 into r to r. And here we have a minus 1 upon 3 whole raised to the power r into 1 upon x raised to the power r. So simplifying further, we have 6cr 3 upon 2 raised to the power 6 minus r, then we should take minus 1 upon 3 raised to the power r. Then we have to simplify this. So as we know, by the theory of indices, the power r is subtracted from the power of the numerator. So we have x raised to the power 12 minus 2r minus r. Finally, we have 6cr 3 upon 2 raised to the power 6 minus r minus 1 upon 3 raised to the power r and x raised to the power 12 minus 2r minus r means minus 3r. Now we have to equate the power of x to 0 because we need to find out a term independent of x. So let 12 minus 3r is equal to 0 or r is equal to 4. So if we substitute r is equal to 4 in this term, we have on the left hand side, because we have tr plus 1, so it becomes 4 plus 1, that is 5. So on the left hand side we have t5, that means the fifth term will be independent of x, and 6c4, because r is 4, everywhere we have to substitute r is equal to 4, so we have 6c4 into 3 upon 2 raised to the power 6 minus 4, that is 2, and minus 1 upon 3 raised to the power 4, and it becomes 0 automatically because we have equated to 0. So x raised to the power 0 will be 1. So this term will be independent of x. Now simplifying this, we have factorial 6 upon factorial 4 into factorial 6 minus 4 multiplied by 3 square upon 2 square multiplied by, if the exponent of minus 1 is even, so it becomes plus, so it will be 1 upon 3 raised to the power 4. Simplifying further, we have factorial 6 upon factorial 4 into factorial 2, 6 minus 4, and now here 3 square will cancel 2 parts from the denominator, so we have 1 upon 2 square is 4 into, and here is left 3 square, that is 9. Simplifying further, if we cancel factorial 4, that is 1 into 2 into 3 into 4 from factorial 6, we are left with only 5 into 6 in the numerator, and in denominator only factorial 2 is left. Factorial 2 is 2, 1 upon 36. So now simplify this, 2 3 is 6 and 3 will cancel 36 12 times. So finally we have 5 in the numerator and 12 in the denominator, and the fifth term, that is the independent term of x in the expansion of the given binomial, is 5 upon 12, and that is our final answer. Now the next important type of question is where we need to find out coefficient of a given variable factor, that is like x raised to the power 10. So we need to find out here the coefficient of x raised to the power 10 in the expansion of 2x square minus 1 upon x raised to the power 20. So let's do it. So first we have to compare this binomial expression with a plus b raised to the power n. So we have a is equal to 2x square, b is equal to minus 1 upon x, and n is equal to 20. Then we should write tr plus 1. Tr plus 1 is ncr a raised to the power n minus r, b raised to the power r. And we need to substitute the values of a, b and n in this identity. We have 20cr 2x square raised to the power 20 minus r minus 1 upon x raised to the power r. Now simplifying this, we have 20 cr. Here if we open up this bracket, this power 20 minus r will go on both numerical factor and variable factor, that is 2 raised to the power 20 minus r and x square raised to the power 20 minus r. Then both the exponents of x will be multiplied together and we have 2 into 20 40 minus 2 into r minus 2r. And here we have minus 1 upon x raised to power r. So when we open up this bracket, this power will be given to minus 1 and x both. So we may write it as minus 1 raised to the power r upon x raised to the power r. So further we have to simplify this 20 cr 20 raised to the power 20 minus r, and then minus 1 raised to the power r should be taken, all the numerical factors together, and then we have to simplify x raised to power 40 minus 2r upon r. So by theory of indices, when the bases are same, the power of denominator will be subtracted from power of numerator. We have x raised to the power 40 minus 3r, because 2r minus r will be 3r. In this step, we have to observe that which is that variable factor whose coefficient is required, that is x raised to power 10. So in this expression, the power is 10. So we have to equate this expression with the given power of x in our question. So let 40 minus 3r is equal to 10. Transposing 3r to that side and 4 to left hand side, we have 40 minus 10 is equal to 3r. 40 minus 10 as 30 and 3r on the right hand side. Then we transpose 3 to that side, it will divide 30, and ultimately we have r is equal to 10. So now we have to substitute this obtained value of r in this equation. Tr plus 1 is equal to 20 cr 20 raised to the power 20 minus r minus 1 raised to power r, and x raised to power 40 minus 3r. So we get t 11, because here 10 plus 1 will become 11. So that is equal to 20 c10. Next 20 raised to the power 20 minus 10 and minus 1 raised to the power 10. And here the power will be 10 automatically, because we have equated 40 minus 3r to 10. So if you substitute r is equal to 10 over here, that will be 40 minus 30, that is 10, x raised to the power 10. So simplifying one step further, 20c10 into 20 raised to the power 10 minus 1 raised to the power, even exponent is always positive, so it becomes positive, and x raised to power 10 is left. So the coefficient of x raised to power 10 in the given expansion will be, so finally our answer is the coefficient of x raised to the power 10 in the expansion of 2x square minus 1 upon x raised to the power 20 is equal to 20 c10 into 20 raised to the power 10. Now the next most important type of question based on binomial expansion is if we need to find out a particular term in an expansion from the end of the expansion. Be careful, from the end we need to find out fourth term, not from the beginning. So as we know, tr plus 1 from the beginning, ncr a raised to the power n minus r, b raised to the power r. And if we write tr plus 1 from the end, then what we have to do, we have to replace r by the difference of prefix and suffix, that is n minus r. So we write nc n minus r. Second thing we have to do, we have to interchange these exponents of a and b, so there will be a raised to the power r and b raised to the power n minus r. After that, we have to compare our given expression with the standard binomial a plus b raised to the power n. A is equal to x cube upon 2, b is equal to minus 2 upon x square, n is equal to 9. We need to find out fourth term, so we have to think which value of r makes the r plus 1 4, that is 3. So if we substitute r is equal to 3 over here, that will be 3 plus 1 4, that is t4, and we need to find out t4, that is fourth term. So r should be taken as 3. So if we substitute these values in this identity, so we write tr plus 1 t4 from the end, because 3 plus 1 is 4, t4 from the end. N is 9. Here 9 minus r, that is 6. N is 9 and r is 3, so 9 minus 3 is 6. And a is x cube upon 2, and its power is r, so r is 3. And b is minus 2 upon x square, so minus 2 upon x square, and whole raised to the power n minus r, that is 9 minus 3. 9 minus 3. So simplifying, we have 9c6 x raised to the power 9, 2 raised to the power 3, that is 8, multiplied by minus 2 raised to the power 6. And if the negative integer has even power, it becomes positive, so it becomes 2 raised to the power 6. And here we have x raised to the power x square raised to the power 6 becomes 12. X raised to the power 12, 6 to the 12. So finally we have 9c6 and 2 raised to the power 6. Here 8 is 2 cubes, and 2 cube will cancel 3 powers from the numerator. We have 2 raised to the power 3, and x raised to the power 9 is there in the numerator, x raised to the power 12 in the denominator, so these powers will be subtracted from the denominator. We have 1 upon x raised to the power 3, c6 into 8 upon x cube. We may also further simplify this using NCR for solving 9c6, or we should leave answer over here. So these are the 5 most important types of questions based on binomial theorem.